In 1977, NASA launched Voyager to explore the outer planets. But decades later, it hit something no one expected: a 50,000-degree wall of fire at the edge of the solar system. This wasn't a myth or a glitch. It was real data, showing where the sun's power collides with the galaxy itself. What exactly did Voyager encounter out there? And why did it leave NASA in shock? Let's dive right in. When NASA launched the twin Voyager spacecraft in 1977, no one imagined that these small, golden explorers would one day rewrite humanity's understanding of the solar system itself. For decades, they quietly traveled outward, far beyond Jupiter, Saturn, Uranus, and Neptune, further than any machine had ever gone. And just when the world had almost forgotten them, the Voyagers sent back a message that stunned everyone at NASA. They had reached the edge, and what they found there was impossible. Voyager's instruments began detecting an abrupt rise in temperature, up to 50,000 Kelvin, in a region that was supposed to be cold, empty, and silent. It wasn't an illusion. It wasn't a glitch. Both Voyager 1 and Voyager 2 confirmed it. A mysterious wall of fire standing at the edge of the solar system, glowing not with light but with energy. For a moment it seemed like science had hit a paradox. How could a region so far from the sun, so empty that it contained fewer than one particle per cubic centimeter, be that hot? NASA's top physicists spent months rechecking the data, but the conclusion was unavoidable. Voyager had crossed into the heliopause, the invisible border where the sun's power collides with the galaxy itself. What Voyager found was not a solid wall, but a frontier, a chaotic sea of charged particles, magnetic turbulence, and heat unlike anything seen before. It was as if the solar system ended not with silence, but with a roar. Inside the heliosphere, the sun constantly blows out a wind of charged particles, racing through space at nearly 1,000,000 miles per hour. That solar wind forms a vast magnetic bubble around us, protecting every planet, from tiny Mercury to distant Pluto, from the deadly cosmic radiation of the galaxy. But as that solar wind pushes outward, it eventually meets the thin, invisible gas between the stars, the interstellar medium. When the two collide, pressure builds. The sun's wind slows down, compresses, and heats up violently, creating a layer of plasma that can reach tens of thousands of degrees. That's the wall Voyager detected, the point where the sun's reach finally breaks against the galaxy's opposing force. To NASA, it was one of the most profound discoveries in space exploration. The boundary of the sun's influence, a cosmic line separating what's ours from what's not. And yet, the more they studied it, the stranger it became. Voyager 1 crossed the boundary in 2012 at a distance of 121 astronomical units. 6 years later, Voyager 2 crossed at 119. That tiny difference might sound trivial, but to scientists, it was a revelation. It meant the boundary was breathing, expanding and shrinking as the sun's activity changed. When the sun flares and storms, the bubble grows. When it quiets down, the wall contracts. The solar system, it turns out, isn't fixed, it's alive. Even more surprising was what happened to the magnetic field readings. Scientists expected the magnetic field inside the heliosphere to point in one direction, and outside it to flip dramatically. But both Voyagers reported something shocking. The two fields were almost perfectly aligned. That meant the supposed edge of the solar system wasn't sharp at all. Instead, the sun's magnetic field smoothly blends into the galaxies, like two invisible oceans merging together. The solar system, once thought to be an isolated island, turned out to be part of a vast, connected sea of energy. It was a humbling moment. The sun, the star we thought ruled our tiny neighborhood, was just another participant in a grand magnetic dance with the Milky Way. But this discovery wasn't just poetic, it was deeply practical. The heliosphere acts as our shield, blocking much of the galactic radiation that would otherwise bombard Earth. Thanks to Voyager's data, we now know that this shield isn't constant. It breathes, it weakens, and sometimes it leaks. During periods of low solar activity, when the solar wind is weaker, cosmic rays can slip through the wall more easily. That means radiation levels across the solar system can rise, affecting satellites, electronics, and even the safety of astronauts traveling beyond Earth's magnetic field. The Voyagers didn't just map a frontier, they gave humanity the first real understanding of how the sun protects us and how fragile that protection really is. It also raises questions no one can yet answer. If our sun has this wall of fire, does every star have its own? And if so, could the strength or shape of that boundary determine whether a star system can support life? NASA believes so. Every star generates its own astrosphere, a protective bubble like our heliosphere. Some are massive and strong, shielding their planets from radiation. Others are thin and weak, leaving worlds exposed to cosmic storms. Understanding our own heliosphere helps scientists identify which exoplanets might be safe enough for life, and which ones are doomed. In that sense, Voyager didn't just cross into interstellar space, it opened a new field of science, connecting cosmic physics to the search for life itself. Even now, the two Voyagers continue to whisper from beyond the sun's grasp. Their signals are faint, barely detectable, but every byte of data they send is precious. It tells us about plasma density, magnetic turbulence, and the invisible currents that shape our place in the galaxy. Each transmission takes over 21 hours to reach Earth. Somewhere out there in the dark between the stars, two human-made messengers drift silently, still doing their job after nearly 5 decades. NASA's engineers have been forced to make painful decisions, turning off one instrument after another to save power, stretching every remaining watt from their nuclear generators. They know time is running out. By the 2030s, both spacecraft will likely fall silent forever. But even when the last signal fades, Voyager's mission won't end. They will keep traveling, carrying with them the golden record, a message from Earth etched in copper and gold. The sounds of the wind, the laughter of children, greetings in 55 languages, and the music of Bach and Chuck Berry. One day, maybe millions of years from now, another civilization might find them and realize, somewhere in the Milky Way, there once lived a species that looked up at the night sky and dared to reach beyond it. And yet, for all the poetry and wonder, Voyager's discovery still leaves scientists uneasy. The wall of fire is not constant. It shifts, pulses, and sometimes behaves unpredictably. It's more like a storm front than a fixed border. Recent data even suggest that energetic particles from interstellar space are pushing back harder than expected, squeezing the heliosphere more tightly than models predict. If true, that means our solar system is more exposed to cosmic radiation than previously thought. This realization has triggered a quiet race at NASA and international space agencies to model the heliosphere more accurately. Because understanding how this wall behaves isn't just about science, it's about survival. Future crewed missions to the Moon, Mars, or even further will depend on predicting how much radiation reaches deep space. Voyager's data is now the foundation of those safety calculations. And then comes the next step, the interstellar probe. NASA's proposed successor to Voyager would travel 3 times farther, mapping the heliosphere in full detail, and finally answering one of the greatest questions left. Is that wall unique to our sun, or is it a universal phenomenon around every star? If the answer is yes, then the Milky Way isn't just filled with isolated stars. It's filled with living, breathing bubbles of energy, each colliding, shaping, and protecting its planets. That would mean our galaxy isn't cold and empty. It's alive with motion, heat, and interaction. So when Voyager crossed that wall of fire, it wasn't just another milestone in space exploration. It was the moment humanity truly stepped beyond its cradle. The probes didn't find emptiness at the edge of the solar system. They found activity. They found structure. They found that even in the deep void, the heartbeat of our sun can still be felt, faint but steady, echoing across the stars. And that changes everything. Voyager's story isn't just about discovery, it's about perspective. It reminds us that the boundaries we imagine are often illusions. The solar system doesn't end in silence. It ends in energy, in transformation, in proof that even at the furthest edge of darkness, our star still leaves its mark. Out there, beyond the planets, beyond the light, Voyager found something extraordinary. The sun's final breath, still burning, still protecting, still alive. Voyager's discovery reminds us that the universe isn't cold or silent. It's alive. That wall of fire wasn't an ending, but proof that the sun's heartbeat still echoes across billions of miles. And if the edge of our solar system burns with energy, what else might be waiting beyond it? New worlds, other walls, or maybe signs that we're not as alone as we think. Whatever lies ahead, Voyager proved one thing. Humanity can reach beyond fear, beyond limits, and find wonder where we least expect it. If you enjoyed this story, don't just stop here. Hit like, share your thoughts in the comments, and subscribe to Galactic Breaking News. Turn on notifications because the next discovery might just change everything we know about space. Launched in 1977, Voyager 2 was never supposed to return a signal after leaving the solar system. Yet, decades later, NASA received a strange transmission, structured, intelligent, and far too deliberate to be random. When scientists traced its source, they discovered something chilling. A moon-sized object moving in sync with Voyager 2, as if it had been tracking it all along. What was it trying to do, and why now? Let's dive right in. When NASA first received that faint pulsing transmission from Voyager 2, no one believed it was real. The probe had been silent for decades, floating through interstellar darkness more than 12 billion miles away. Its power was fading, its instruments outdated, and yet, here it was, sending a signal back to Earth. It wasn't a weak, dying transmission. It was rhythmic, deliberate, and eerily precise. At first, the team assumed it was just background noise. Deep space is full of radiation and random bursts of static. But this was different. Every frequency spike followed a pattern that matched something scientists knew well, the Fibonacci sequence. That's a mathematical rhythm found everywhere in nature, from the spirals of galaxies to the arrangement of leaves. It's the universe's signature of order, and Voyager 2 was somehow echoing it. As the data kept streaming in, engineers noticed something even stranger. Instruments that had been turned off decades ago suddenly came back to life. The probe's magnetometer began scanning space without any command from Earth. NASA thought it might be a malfunction, but the system logs showed the device wasn't rebooting randomly. It was orienting toward a specific direction, toward something